hear me and rejoice, for you are all about to get educated by the great Manico. I'm actually really honored to be able to introduce our next keynote speaker, Jim Manico, the man who really needs no introduction, but I'm going to try anyway. By the way, I am Avi Douglin. I'm also on the board of directors, but it's not about me. Jim has been wrapped up in AppSec and OWASP in particular since the very beginning. You can't really talk about OWASP without talking about Jim. Who here has not heard of Jim Manico? Just quick raise of hands. Barely anybody. Jim is project leader for what, half a dozen projects, I think? You got your cheat sheets, you got your proactive controls, a whole bunch of other stuff. Jim is involved. ASVS, of course. Jim is involved in so much of that, and he's done so much more beyond that. Actually, the last time I saw Jim was at AppSec Israel in 2018. He said, this is a quote from him. He actually said, I'm going to come, if I have to run around the streets in my underwear, I'm running around the streets of Tel Aviv teaching people about secure coding. He actually said that. That was a quote. You don't remember that. So that was AppSec Israel in 2018, and I'll take a quick opportunity to tell you AppSec Israel in May, Tel Aviv 2023. Good, yeah. All right, so I'm going to get out of the way. I'm going to let Jim come up here and just, yeah. Jim, go ahead.
I'm so happy to be here. Hello, everyone. How are you doing today? How has your conference been so far? How you doing? You having a good time, I hope? Yes. I think the work that we do is extraordinarily important, and I know that it's not an easy job. I know the kind of stress that all of you are under. The goal of this talk is to zoom out a bit and show you just how much progress we've made in this industry in the life of computer science and information security. And first of all, the reason that we're here is because of these sponsors. So I do want to say thank you to all the folks who spent money to sponsor us so we can have this event and share knowledge together. Thank you so much. I want to share with you some stories about, again, the history of application security, but also a couple things I did to amuse myself during the pandemic in relation to application security using social media to try to propel application security forward in some ways by causing trouble. Okay, so this is an extremely abridged version of what application security is, but again, the whole point of this is that I know you're stressed out. At least most people I know who work in this industry, they're fighting an uphill battle. We're going against the stream of creation to create things in a safer way. And it's just not an easy job, no matter where you are in this industry. There's zero unemployment, but usually 99% stress. And I want to show you a different perspective on things. My name is Jim Manico. I've been a former board member. I participated in the Application Security Verification Standard with Josh and several others. I participate in the Cheat Sheet project as a project leader with about 100 other authors. Lots of other stuff. I love this foundation. My blood bleeds blue of the OWASP Foundation. I do my best to operate like a fiduciary and try to make decisions that are good for OWASP and good for our industry before my personal interests. So anyways, let's go back to the beginning of the application security history. The best that I can come up with is the October '67 Task Force. Now, what is this? This is organized by the Advanced Research Projects Agency, which is now DARPA, the Defense Advanced Research Projects Agency. This is the first time a government is spending real money, real time, with a team of real professionals evaluating the information security posture of the federal government and US military. So this was published in 1970 as R609 classified. This is a fully comprehensive government-level IT security report, and it was even declassified in '75. That's when we got to look at it. But back in 1970, your high-level government intelligence agent, your high-level government IT security, this report comes out, and it's the first time we're really looking at IT security for a major organization. What do you think the report said about the security? Hey, Jay, how you doing, Jay? What do you think the report said about the posture of the US government back in the early 1970s? Yeah, things are a little messed up. It's bad. There's literally a complete and total lack of modern information security. This is 1970. A little more than 50 years ago, some of the most critical systems that ran the world had no security. And that's where we start this story, right about this era. Now, I want to break it down a little bit differently. I want to look at security testing. I know that many of us in the room are security testers by trade. What is our mission? Our mission as a security tester is to discover security bugs in critical software before the bad guys do. You know, we're defenders. We're trying to make things better for the world and the little micro communities that we work in. Well, the first time I could see a pen tester at work is 1938. Do you know who this team is? This is a team that leaped off of Polish researchers to crack Enigma. This is the British team who created the bomb. This is a cracking tool to crack cryptography of German Enigma system, right? How did they build the bomb back in 1938 to crack crypto to save the world? By one historical perspective. If there were different winners, there'd be a different talk. But let's bear with me. So, to save the world back in the 30s and 40s, how did they build the bomb? First pen testing tool that I can come up with in history. What do they use? Vacuum tubes. What else? Hammer, nails, wood, wire, electric wire. They built it not with software while drinking a latte, Andrew, right? They were physically building a physical device that they had to crank to crack crypto to save the free world. That's where pen testing started. Hammer and nail, right? Hammer and nail. So now we're getting into the modern era. It's now 65. William Matthews from MIT finds a security bug in Multic CTSS. So this is the first multi-user computer in history. A bunch of students at MIT are using this. And this is the first time we see real access control needed because you have one of the first early multi-user systems. There's a message of the day, right, that would cycle through all the message of the days. And the last one was a buffer overread that would pop a random password to one of the users. So it's mess of the day, mess of the day, mess of the day, someone's password. This is not the best security, by the way. But this is truly where security testing begins. William Matthews is one of the first security testers in modern history. And his protege around the same era in the same system, one of the key researchers would actually purposely override the operating system code because he had admin access as an employee there to change the amount of time it showed him using the computer so he can use more for his research. One of the first hackers in modern history as well shows up in the mid-60s. So what else do we have here? We have 72, the Anderson report comes out. 74, the Air Force in the United States begins the first real comprehensive IT security program on the planet that I can find historically. Now we have a team of security testers reviewing military code, and it's the early 70s. There we go. 79, Lint comes out, static analysis. 95, we have kind of like a wasteland for the 80s. A lot of the IT, I think, stagnates in the 80s. In the 90s, we have the security administrator tool for analyzing networks. You remember when that came out? Anyone remember when this first came out? This is a big deal because it's one of the first major free security tools that did something amazingly impressive. I think in the modern era today, that's what SemGrep is doing to our industry in terms of disrupting static analysis. But this is a big disruption in terms of security in general. We all have a copy of this tool, and it's epic in its ability to discover problems in modern operating systems. 98, Jeff Forrestal, Christmas Day, Frack Magazine 54, the term SQL injection is used for the first time. A famous hacker, Rainforest Puppy, Jeff Forrestal. That's when SQL injection started. How long ago was that? It's like, what, let me get my math right, 25 years ago? A little less? This is not that long ago in modern engineering history. So AppSec is barely starting at this point in the late 90s. In the late 90s, our industry is barely beginning at this point. At about 99 now, this is where Gary McGraw and Cigital is selling static analysis and code review and scanning services. The first time a US company is actually selling security services. This is a golden era. Microsoft calls cross-site scripting as a term for the first time. We see ITS-4, real security static analysis, being released by John Viega. This is really where our industry begins, 99. It's game on. The industry from that point on begins to accelerate at an exponential rate. 2001, our foundation, the Open Web Application Security Project by Mark Curphey, is created for the first time in 2001. We see 2003 Metasploit shows up, and we could take out networks pretty easily by clicking a button, 2003. 2008, the OWASP testing guide, SQL map all begin to hit the scene. 2009, DevOps starts at Etsy, the real beginning of the modern continuous integration, continuous deployment movement. A lot of people are talking about it in 2008, 2007, but Etsy is betting their entire billion-dollar company on doing DevOps and doing it right. This is Zane Lackey, Nick Galbraith, and this is the original DevOps team working at a great scale. How did it affect their company? It turned them into a multi-billion-dollar company, let them beat their competition really quickly. They're still a giant company to this day. 2010, Simon Bennett releases Zap. We also see in 2013, Defect Dojo comes out. Anybody play with Dojo at all? Defect Dojo, open source CI/CD. We would spend millions to build something like that. And now OWASP has an open source product to do full software orchestration. It's epic in what it's capable of doing, right? So 2015, Jeremy Long, go ask Jeremy why he started the project. I'll give you a little someone starts teasing Jeremy because they wouldn't give him a discount. They're like, go ahead, Jeremy, who's working for a big bank at the time. Go ahead, Jeremy. You don't want to spend money on our product? Then go build it yourself. Well, 2015, he released it. He did just that. And it's now one of our flagship projects. 2020 is the beginning of the modern threat modeling era, in my opinion. Threat modeling had a lot of problems, a lot of BS in threat modeling. I only see maturity there in the last 2 or 3 years. And I believe the Threat Modeling Manifesto begins that era. That's about where we're at today. Welcome to the history of your industry. What's the point I'm trying to make? Is that go back to the beginning here. What were we doing? Hammer, nail, wood, and wire to crack Enigma with the crank, literally, a physical crank to crack crypto. And where are we today? I can go download Zap. I can go grab SemGraph, I can go grab Dependency Check, I can go grab Defect Dojo, and for free, through the OWASP Foundation, what can we do? Build a full security orchestration framework in about 10 minutes. That's how we've changed as an industry if you zoom back and look at what we've done. We've done some impressive things to try to help the world be a more secure place in some way. And so, where are we today? Security testing, fully integrated into GitHub in a variety of different mature ways. We have DevSecOps capabilities in the open source and commercial world, SaaS, DaaS, SCA, and even the IaaS category. Hey, Jeff. Pen testing, AppSec services are still expensive. There's not enough of us out there. We haven't reached even full maturity yet. We need to have a full staff in the industry to do that. We're just not there yet. And I think one of the most important things in testing history is the OWASP Mobile Testing Security Guide and the Mobile Application Security Verification Standard. They're being used for compliance by some of the largest companies in the world right now. I've had like some of the top 5 governments, some of the top 5 software companies call me, and the ASVS and the MASVS team calling us, telling us, we're going to standardize our government on this standard. And I'm like, oh, really now? I'm not kidding. So that's how things have changed in a relatively short amount of time. Let's take a look at HTTPS. What is this clock ticking down in front of me, Avi, by the way? That's my time? Yes. All right, HTTPS. So 1994, Avi, 1994, Netscape creates the initial protocol and live version of HTTPS on the client. Has anybody heard Moxie Marlinspike talk about this era in history? Do you know what the engineer said about the authority system that runs the world today? Do you remember that part of the story? So Moxie Marlinspike did a real famous talk on the history of HTTPS at Netscape back at Black Hat before the pandemic. The engineer who created HTTPS, does everybody know why the certificate authority system is so important? Why is that? So when you get the first public key in a TLS handshake from a server primarily, we know it's actually from that server because we have a digital certificate. How do we get that public key signed? By an authority that's got the public key in the browser. That's a quick explanation. But the point is, the whole authority system that guarantees integrity for the entire world software system was a hand wave. He's like, well, why did you make the authority system? I'm like, yeah, somebody could have intercepted that public key, so I kind of just wrote down authority system. And so the whole point is, the whole PKI system that manages the integrity of the world's software, websites, and more was created in a hand wave at the end of a standard process in '94. Was not thought out at all, wasn't described. It was, we got to do this eventually. And that was, again, not that long ago. We jump ahead to '99, TLS 1.4 shows up as a standard. And it is a mess. When we look back on it historically, they made a lot of major crypto problems at a low level in that standard. And guess what? It's something that if you have turned on today, it's a weakness. Most security scanning engines, if they see you with TLS 1.0 turned on, they'll down flag it, like SSL Labs and similar. So it's only in '99 it came out. Today it's awful security in a very short amount of time. 2006, we have TLS 1.1, and in 2008, TLS 1.2 as standards are released. And if you're running TLS 1.1, most evaluation engines will downgrade you. It only came out, what, like less than 20 years ago. TLS 1.2 is the minimal acceptable protocol version that we see today. And 2009, SSL Labs shows up on the scene. They release it to the public as a way to verify configuration. It's now the de facto standard across our whole industry. Go check your site out in SSL Labs. It's a free little evaluation tool. 2010, we see Firesheep released. Anybody remember Firesheep? Oh, this is a great era. Overnight, I can run a plugin in a Mac machine running Safari, and I can fire it up and go listen at the coffee shop and see all my friends' sessions in Facebook, in Google, in Gmail, in Etsy, in eBay, and every major service on the planet at that time. This one move in 2010, it caused the whole world to upgrade their sites to HTTPS across the major players. 2011, forward secrecy shows up. 2013, 10 years ago, is when TLS 1.2 first shows up. It's the minimal protocol you need today to get TLS right. 2015, Let's Encrypt, a free certificate authority, shows up and changes everything. And I feel like this is the beginning of the usable crypto era historically. At this point, we got Amazon, Azure, and Let's Encrypt all working on different things like turnkey key management, turnkey crypto storage, a very rigorous authority that's giving out free certificates. This is where we have Google Tink, the primitives of Google Tink being written. We see libsodium by Dan Bernstein in Chicago being written, and all the primitive components that give us easy-to-use data protection and cryptography are being built, are just starting to have the first versions out around this era. Today, I can go to AWS or Azure and click, click, click. I have some pretty world-class crypto solutions that are easy and usable for developers to build. How far have we come in such a short amount of time in our industry when you zoom back and look at it? And by 2016, half the web is HTTPS. Chrome 51 defaults to TLS as early as 2016. 2017, the CAA group becomes CAA, Certificate, CAA, Certificate Authorization, help me out, CAA. Who's got this acronym? Certificate Authority Authorization, there we go. This becomes default in 2017. Let's Encrypt gives us wildcard in 2018. TLS 1.3 goes live. TLS 1.3 is magic. Why? Because they added new things? No. TLS 1.3 strips the protocol bare, removes all the unnecessary garbage from TLS 1.2 and 1.1, and simplifies it. Who would have thought that after all this work, 20, 30 years of modern crypto, the final protocol that shows up protecting the world is not something that's massively complex, but something that is beautifully simple. They support a small number of ciphers, a small number of modes, and it's clean, it's easy to understand, it's easy to mathematically prove that it's been built right, and this very simple protocol now runs the world, TLS 1.3. 2021, we see the new Certificate Protection Consortium being started up, and Chrome 91 fully defaults to HTTPS. How far have we come? 1994, some engineer at Netscape building the authority system as a hand wave. And in 2021-22, we have a mature management consortium running TLS. We have a great version of the protocol that's simple and provable mathematically that we did it right, and it's easy to deploy and easy to verify. How far have we come in a short amount of time? So here we go, 2021, Chrome 90. If you type in a domain, Chrome began flipping to HTTPS by default. This is a big deal. This is not just a little bit of a big deal. This is a radical decision by one of the leading browsers in the world to default to something that protects people. November 2022, 96 pages loaded in Chrome or Mac OS is HTTPS. And if you go back to March 14th, 2015, the beginning of the TLS, the beginning of HTTPS, 2015, the beginning of the modern TLS era, 43%. How far have we come in 7 years? It's been radical. It's been a radically transformative 7 years for modern web security, and that's our work. This is my domain. I'm trying my best to do it right. I want you to do it right as well. Take a look at SSL Labs. I'm not trying to highlight the company. SSL Labs is the de facto standard in how to evaluate your websites for TLS. You know what the most common answer I get for bad grades? Oh, that's the marketing site. We have no control of that. No excuses. Fix your website. Come on. All right. One more. So password history. Let's talk about password storage cryptography, shall we? How you doing? Everyone doing all right? Doing good? Ready for the next one, everyone? Let's do this. So 1961, we have the first password-based system created. That's the same system I mentioned earlier. That's MIT CTSS. This is led by the amazing Fernando Corbato. He is so important because he is the first engineer to build a password protection system for authentication. And as he was writing about it, about the engineering they were doing, he's like, I am certain I am not the first to do this. Somebody must have thought of this before. No, Fernando, no one has. You're the first one to do it. So 61, the very first password-based system shows up in modern engineering. And by 66, Alan Scher requests a printout of the master password file. Now, Alan Scher was working with Fernando. He was one of the engineers maintaining the system. And everybody only got a small time slice of this system. And, well, Alan Scher didn't like that policy. So he used his admin capability to print out the master password file because he realized there was no admin lock on it. If you knew the location, which was obscure, but if you knew it, which he did, he was an admin, he could print it out, and he did. And guess what? He can now use as much time on the system, had all the other admins' passwords as he wanted. He's famous because he truly is the first password hacker in all of history. This is 1966. So by the 70s, we see that Crypt3 is released in Unix. This is one of the first primitive algorithms to try to store passwords in a secure fashion. And it uses, frankly, M209 code from World War II. This is really bad. They took a bad algorithm from a bad piece of hardware and put it into Unix as early as the early 70s, right? So this is some really bad decisions, but it's the beginning of trying to get it right. So Crypt3 is released in Unix in '78. It's now based on DES, which was good at that time. Bear with me. It's the first time we see real crypto in play with password storage. We got stretching, right? We have salting. We have password policy. Stretching is when you're doing like iterations. Salting is when you add a random string to your password before you protect it. And an actual policy in the operating system. That's '78. Now let's start to jump ahead here a bit, right? The '80s, we have the first admin-protected operating system in the '80s. Now go back, '66, Alan Scher is printing out the password file in '66, and we didn't figure out for 25 years after that hack that maybe only admins should look at the master password file. So that took a while to figure that one out. MD5 shows up in '91, one of the most popular password protection algorithms in history. That's a tragedy, by the way. We should not be doing that, but that was what happened. Let's jump ahead a bit. So bcrypt, that's the first modern algorithm that is still acceptable by some people's standards as an acceptable password storage algorithm. The bcrypt password storage algorithm. It's got 128-bit salt, and it's good even today by some people's standards. We jump ahead. The year 2000, PBKDF2 shows up. This is the North American standard for password storage today. That shows up in the year 2000. 2007, PHP starts using a native protection algorithm using bcrypt as core to their language. PHP, a lot of us make fun of the language because of how hard it is to lock down for various reasons. But PHP, as we're going to see, is a real leader in adapting progressive algorithms early. So they do a good job at making the right things at least available to us as a language. 2009, we got Colin Percival, PhD mathematician, creates scrypt. Again, one of the few algorithms acceptable for password storage. We see 2015, Argon 2 wins the password hashing competition that was out just a few years ago. And today, in 2018, 2016, Dr. Akue Devdatta, he's a security architect for Dropbox. Around this era, we see these primitive algorithms available. We're not sure how to use them. There's problems in using them. Dr. Akue Devdatta from Dropbox, he publishes this famous article outlining step-by-step, meticulously, how to store passwords in a modern service. This becomes the gold standard among other instructors that I know of in our industry who teach how to do this right. He breaks it down in a way. So I used to just use bcrypt. That's not a good piece of advice. He gave more surgical advice that all of us instructors began copying so we can teach people the more meticulous way to do it correct. Real famous point in history. 2016, for the first time in history, I have a formula to protect a password in a secure way that would still work today. 2016, 6 years ago. 6 years ago. And now we're looking at 2019, PHP natively supports Argon 2 ID. This is the famous article, you should read it, by Dr. Devdatta Akue. First time we get architectural level eyeball on how to store passwords right. Argon 2 ID, the gold standard in password security, is supported everywhere. And the OWASP cheat sheet, I got some mathematicians to help us do this. We have really surgical advice on how to store a password with exact settings, depending on if you got more CPU or if you got more RAM available. So there we go. That's where we've come. In a very short amount of time, we went from, I'm like building a password system in '61 in a plain text file that you can print out, to one of the most popular languages in the world has a good protection built in natively. And the cheat sheets here at OWASP give real practical advice, meticulous advice on how to use this algorithm in a proper way. All right, this is my take on the world, though. I don't like bcrypt, and that's a fact. Argon 2 ID is where it's at, because bcrypt has a 72-byte limit. Kiss my ass. Low RAM usage, no thanks, I'll pass. Just messing around on Twitter, talking crap about bcrypt. This is how I live my life, Andrew, during the pandemic. The pandemic was a little freaky. I'm used to traveling. I'm just sitting in my basement. So what am I doing? I am writing little raps about bcrypt in my basement. That's my pandemic experience. Okay. Is everybody okay with that? Are you okay with that? Is that a good use of your pandemic time? Now, we have Jeremy Gosney, who's actually one of the members of the password hashing competition, come back to me and say, Argon's a KDF and that's no cap. If you're doing real-time auth, you need bcrypt in your app. Memory hardness has no meat, it's all fat. For resistance acceleration, cache hardness is where it's at. I'm like, oh, it's game on. I got an actual password cryptographer commenting on my rap saying bcrypt is good, Argon is not, and it's game on, Jeremy. Let's do this, Jeremy, let's do this. All right, Jeremy Gosney, principal software architect, mathematician, member of the Hashcat team, and a password cryptographer decides to rap with me. Let's do this, Jeremy. Argon 2ID won the password competition. For password storage, you need a little revision there, Jeremy. Bcrypt truncates, and that's a fact. It's a shitty limit. It's easier to attack. Argon 2ID has better password cracking resistance. And Jeremy, I'm here to help. Here's a reference, the OWASP cheat sheet series. I'm telling you from the most world-famous mathematician in this area. And he's texting me like, now I'm pissed off. I'm coming at you, Jim, with more poetry. Okay, so which one of us is the cracker? You seem to forgot, and a Hashcat developer. Oh, I think you are not. I'm not. And a password competition, I was a judge for that too. With all these credentials, who is OWASP to argue? The other judges outvoted you, Jeremy, and 1 + 1 still equals 2. Thank you very much. I'll take a win on that one. So no. We're just joking. We're joking around. Jeremy and I work together. He's a friend of mine, and he did get outvoted in the password competition. Bcrypt where factor 10 is decent, but look at Akaway's advice on pre-hashing first, and whatever. Yeah, you could talk poo about PHP, but it natively supports Argon 2ID. This is my little poem as well. I give PHP a lot of credit in adapting these modern algorithms and adapting them earlier than any other language. The clock is showing me 30 minutes. How are we on time? We doing all right? Keep going? Let's do this. Okay, so OWASP project history. So the OWASP Foundation was created in 2001, right? This is when the foundation was actually founded by Mark Curphey. The mission was to help software developers write more secure code. There just wasn't a lot of people who cared about that back then. So OWASP kind of morphed into more of a security testing organization. I think that's just dandy. You know, I'll tell you this. I was a board member for quite a few years. I've seen it all at OWASP, from how we build conferences, how we build projects, how the staff operates, how the board operates. I've had a chance to be a part of all of that in some way. And I like OWASP the way it is. And it changes. Part of liking OWASP the way it is I like the way it changes too. I like as new board members come in, they steer us in different directions. I see how the volunteers are a chaotic group of bees doing all kinds of different things that interest them. And everyone I talk to has some complaint about OWASP. And that's okay. We're passionate about this foundation. But people ask me that same question. What do you want to complain about OWASP? I'm like, well, nothing. I like it the way it is. I like to see new people come in and lead. I like to see new leaders come in and direct it in different directions. I like the staff being treated with respect. That's my bottom line. When I see staff members treated inappropriately, I pull my knife immediately. That's the only line I have. Be nice to our staff. Don't be a dick to staff. A lot of us have done that in the past. It doesn't help. But overall, I look at OWASP. I like it the way it is. And I like it as it changes over the last 20 years as well. My blood does bleed blue. All right. So 2002, the developer's guide comes out. In 2003, we had the first OWASP top 10. These are 2 documents that, for free, really talk about web-based risks, the heart of our organization's mission. And we see 2002, the first developer guide came out. The services that would teach developers about security back in 2002. Well, hey, Andrew, 2002, if you wanted to buy a developer's guide for your company, what would they pay Aspect back then just to write a secure coding guide for that company? A good one, let's say a good one. Yeah, so we're charging like $50,000, and that's the low end to write a developer guide for a company back in 2002. This is just minting cash. And at this era, when that knowledge is precious and not often known and super valuable, Owen Keary and group publishes a free guide with all this information. This is an amazing publication for that era. It's, again, a big disruptor, providing information for free that the world needs, that people were making a lot of money doing. So I'm really proud of this team back in that era. It took really private, secret Illuminati knowledge and passed it for free to the world, which we need to do to move things forward. 2006 is one of the biggest years in OWASP history in terms of getting things done. This is one of the, this blip in time where everybody who's in our industry was zoomed in on OWASP, wanting to do something in some way to move things forward. The testing guide, CLASP, Reform, and ISAPI, some of the old school flagship S projects were all begun back in this era. And I think it was one of the there's many golden eras, but this Andrew, myself, Jeff Williams, and hundreds of other people, it's a really special era in our organization's time where our organization's growth began going from fast to exponential to the big kind of international organization that we are today. ASVS 2008, who was that? Who started ASVS? Mike Babursky. Mike Babursky, who disappeared. I don't know where, I see him once in a while pop up, say hello. Mike Babursky, Dave Wickers, and Jeff Williams, they mint the first version of ASVS, the Application Security Verification Standard. Josh Grossman right there is one of our project leaders. I'm one of the leaders. We also work with Daniel Cuthbert and Elar Lang. Elar is my favorite. Is Elar here? So Elar is great. Elar shows up as a volunteer, adding notes to ASVS more than we were as leads. And at one point he's like, is anybody home? I'm working here. Will you please answer my damn email? I'm getting frustrated. So he's talking smack to us. And Elar, anytime I would say something about how I think things would be done, Elar would disagree with everything I said. I'm being dramatic. This is a dramatic interpretation, Josh, right? But in a real smart way. I'm a developer, he's a pen tester. We come from two different angles. So we always disagree on small things. So what do we do, Josh, with this guy Elar, who wouldn't stop hassling us and talking smack to us and disagreeing with us? What do? We made him one of our co-leaders. He's now one of the leads of the standard. Yeah, it's like, and think about this carefully. We have a 3-person leadership team. We run the standard. It's a big, honestly, it's a big honor to do so. This is an international standard that a lot of people are pointing at. This one loud guy in Estonia really talking a lot of smack to us. He's good at it too. He's getting personal with us. What's wrong with you? Are you too busy to answer my email while I'm sitting here working in Estonia to make standard better? Come on, what the hell's wrong with you? He's really talking smack, disagreeing with us. We made him a leader. I think that's a big deal. He's crushing it. He's a monster in terms of helping the standard move forward. He's our current lead on the whole standard. So that's what we did as a team. This is what you should do at OWASP. This is why the foundation is great. We found someone smart who was willing to participate and significantly disagreed with us, had a different perspective, so we brought him in to lead with us. And this is what I want all of us to do. This is what makes OWASP great as a foundation. Guess what, Jay? We're going to disagree sometimes on security architecture. We are. And we can still work together. And as we work together, I've taught class, and you've been a student many times. As we work together, I learn more by your disagreements. And hopefully you learn by mine as well. But we disagree on things. And we make each other better because of that difference and because of those disagreements. It's not when we get along and things are easy and we're getting a project done That's not what makes OWASP great, in my opinion. It's when we come together with radical differences, variety, different perspectives, different ways of operating in a project, and we still work together to move application security forward. That's what makes OWASP special. Not what binds us, but what's different about us all, is my opinion. And I see that in ASVS. Josh, we're different, Josh. We go about things a little bit differently, my friend. I like to raise my sword and check in changes to requirements. And Josh is like, Jim, I have a suggestion. Let's think about it first before we radically change the standard. Okay, I agree. That's the way to roll. Okay, I'm gonna move on. I'm sorry, Josh. I'm good. 2009, the OWASP Top 10 Release Candidate 1 comes out. This is one of the bigger versions of ASVS. This is one of the bigger versions of the Top 10 that standards are picking up on now. PCI DSS, STIGs in the military, FTC regulation. This is the era where the top 10 is being rolled into international standards and everybody is looking at it. The XSS prevention cheat sheet is published in 2009. Why is that a big deal? Anyone know why? This is Jeff Williams. The XSS prevention cheat sheet is published right around this era. This is the most frequently hit page in the history of the whole foundation. By itself, it's seen millions of page views. Come on, this is a cheat sheet on cross-site scripting defense on a media wiki page. And it's seeing millions of hits. That's the impact we're having across the world as a foundation. And this is a really critical point in time now. We're exponential. Millions of people and engineers are looking at our work, and the name OWASP has become pretty common throughout the entire industry. 2010, the OWASP mobile project starts with myself and Jack Manico, and it's now turned into the mobile application testing guide, the mobile application security standard, and Google picked up the MASVS as their standard for regulators. That all started back in, that all starts back in 2010. 2010. A few security-minded mobile folks are talking about mobile security. And 12 years later, the largest software manufacturer in the world is asking for our help because they need a standard to show to regulators built by a third party so the regulators get off their ass so they can get their job done. And they point to OWASP as the standard they're using for mobile development. That's a big deal. It's not just Google. It's a dozen big companies and governments asking for our help to use our standard for their work. This is a big deal. And it's not Josh and I. It's like, how many people volunteer with this standard, Josh? 100 or so? Yeah, so it's like this is a huge community of people who are doing this work to try to make the world a more secure place in some way. 2012, Defect Dojo work begins. This is one of the most heavily hit projects in OWASP history in terms of number of downloads and community of users, next to Zap. What else do we have here? 2014, the Juice Shop begins. This is one of our German members. How do I pronounce this right? Bjorn? What's that? Bjorn. Bjorn is a barrel of joy. I miss Bjorn. I haven't seen him in years. But Bjorn builds a full juice application from scratch for modern spa-based microservice applications as a capture-the-flag system that we can use as a trainer to do security testing on. And this is a project he's been maintaining actively since 2014. It's become a common application that we can talk about among security testers and educators around problems that we see in the real world. And here's someone that gave us a running app that we can use to attack and test and train with as a common language so we can learn about modern security architecture. 2015, the dependency check that Jeremy started, it starts in 2015. It's flagship soon after. We mentioned that a few times. Let me jump ahead here a bit. What else do we got? 2018, IoT Top 10. By 2022, there's the cheat sheet project goes flagship. There's now about 50 plus different publications we're maintaining. I'm missing a dozen projects or more that we could talk about. But the point I'm trying to make is that the projects that OWASP puts out have a global impact in terms of giving us testing capability, in terms of literally setting the standard for application security, to providing educational materials that radically helps engineers understand these difficult ideas. And look at this. I mean, this is billions of dollars worth of work right before us, and this is what our foundation has come up with. What else? Winding down here. Let's do one more. Let's talk about the history of cross-site scripting in my final 19 minutes. I'm usually giving a keynote for like 40 minutes in and out. This is the first long-form keynote I've given in a long time. So here we go. Let's do it. Cross-site scripting. Cross-site scripting really shows up in 1999. Some engineer at Microsoft coins the term cross-site scripting. Now, by the way, is this term correct? Should we have named this category cross-site scripting, Avi? Should we have? Every word in that is wrong. It's not cross-site, and it's not necessarily a script. I can use HTML to do content, and content injection would have been the better name. But this term stuck. We still use it today. We'll probably use it in 10 years. But cross-site scripting, the misnomer for content injection, that history begins in '99. Again, not that long ago. 2002 is when Microsoft flips on HTTP only in Internet Explorer 6. What does HTTP only do? You know? I mean, what's your name? You know what HTTP only does? What does it do? It protects cookies for being read via JavaScript. High five. He knows. He's like, I know. Of course I know. Excuse me. Of course I know. Okay. 2002 is when that got flipped on. This is not a great defense, actually. It stops cookies from leaking, but it doesn't stop me from abusing a cookie. I can still force the cookie to be used, do stored request forgery. It ends up not helping that much, to be honest, but it's the first defense in place in a series of many other standards that have been rolled out since the beginning of this era. We look at 2004, this is where Robert Hansen, known as R-Snake, he publishes a proposal called Content Restriction Standard. And this is the predecessor to Content Security Policy. I asked the question, who created Content Security Policy? This is an epic standard for web security. And I get a lot of wrong answers. I want to put it out there. Robert's a friend of mine, Robert Hansen. He's fading away doing his own thing, mostly. But he's the one who created Content Security Policy that is now one of the top standards to stop cross-site scripting. And that work actually came out and was submitted to the W3C as early as 2004. 2005, Sammy, the famous hacker out of Los Angeles, posts this attack to MySpace, where I was working at the time. And Sammy is the first hacker to launch a worm against a social media website. And the thrash from his attack intra-server was so strong because everybody was adding 1 million followers to themselves or being added to other people's lists that had 1 million followers. And the database that was running MySpace at the time couldn't handle millions of users with millions of followers. And the entire global cluster of .NET servers running MySpace blue screen because of this attack. And he took down the entire global MySpace network with this attack. The first web hacker at this level that I know about in history. And a lot of us joke and thank Sammy because he woke up the industry that web security was needed. He did it by doing felonious activity. And Sammy spent years in an orange jumpsuit picking up trash on the streets of LA with the grabber, right? So he served his time. He did the work, but he also propelled the industry. Shutting down one of the biggest social media sites in the world sure does breed awareness. It's not the best way to do it, but it did. 2005 is when Amit Klein first coined the term DOM-based XSS, also a misnomer. Sorry about that, it's a bad term. But it's the best we knew at the time. So these key things that we put so much focus on today began a short while ago. 2006, Reform shows up, the first output encoding library to address XSS that handles 6 or 7 different languages. That's a little project, but in my mind, it was a predecessor to a SAPI in the Java encoding library and other projects that aimed to solve this problem. 2009, the OWASP XSS Prevention Cheat Sheet is published by Jeff Williams, the most popular publication in OWASP history. 2010, the goat love worm hits Twitter. Remember HTTP only? The goat love worm is hitting Twitter and scraping parts of the page to read the request forgery token to force a request that makes you tweet about a love of goats, whose name we probably shouldn't speak of, my friend. But the idea was, even with HTTP-only cookies, this attack was still able to force the use of the cookie, even though we couldn't read a copy of it. An example of a stored cross-site scripting request forgery hybrid type attack that had 3 million people on Twitter saying rather inappropriate things. And another interesting note, in 2010, the entire Apache infrastructure is rooted, and the initial entry point was cross-site scripting. History misses that, but literally the entire Apache foundation was rooted because of XSS. 2011, the OWASP Java encoder, the OWASP HTML sanitizer, written by Michael Samuel from Google, which Google used to protect their Java code, and Jeff Eichenowski, a robotics PhD professor, builds the Java encoder. I think this is important because these are really hard tools to build and maintain, like the predecessor to things like React and the predecessor to things like DOM Purify. These were not teams. These were individual PhDs who understood HTML at the bit level. Or we see like Mike Samuel, who understands encoding at the bit level. These are savant, I know them both well. They are savant geniuses who have an understanding of the web a way a neurotypical will not. And they wrote these libraries that are still production status today, and they still maintain them in some way. So I like that when OWASP is able to harvest somebody with special and unique genius, convert that into a project that will benefit the world at large. These libraries are used all over the world and have been for over a decade. Coming to an end here. So we see the DOM prevention cheat sheet shows up. A lot of executives from banks were participating in that cheat sheet. CSP 1.0 only shows up in 2012. Remember, Hansen is the one who proposes this back in 2004, and blip ahead to 2014, and it's a real standard. Jump ahead to the end here. Whoa, 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 what do we got here? 2015, CSP 3.0 is published, and in 2022, Trusted Types is live. This is Chris Christoph who wrote this. This is a way to stop DOM XSS at the standard body level, at the standard level. It's amazing. It's built into React and Angular. It is adding even more protection to the modern web than any other XSS defense technique has ever given us. It's live. And the sanitizer from DOM Purify, Cure 53, it's now a standard being added natively to the web. So the work of like OWASP, HTML sanitizer, into DOM Purify, and now a native API that drives the web today. So a few more last notes here. Auto-escaping in 2022 is the norm in web-based templates. CSP3 with strict dynamic is easier to deploy and is live in all major browsers. Trusted Types is integrated into React and Angular, and being a little bit of a jerk on Twitter can make the world more secure. Now bear with me on this. So I show up during the pandemic. I believe this at this time. Safari's lack of CSP3 support when every other browser supports it, and other standards that Safari is not jumping into, is a reason for us to boycott it. I'm done with Safari. They're so far behind. And I see Safari as a browser that impedes the secure web because of Apple's hesitancy to really participate in the W3C, to agree on web security standards. Apple does their own thing. It's becoming a problem. Edge, Chrome, Firefox all support this well back in 2021. Why not Safari? And I'm open to counter opinions. Philippe Durick shows up and says, no, this is true, Jim. Safari has a big user base. We need to care about it. Thank you, Philippe. And I'm not trying to harass John here. He's a member of our community. This is John Weilander, who actually runs security for Safari. And if you already know John Weilander, he's an OWASP member. He's about one of the best people I know. He's like, don't worry, Jim. I want to see CSP3 in WebKit as soon as possible and always forward good faith feedback back to the team. And the person in charge is this person here. This is John Weilander. He's the manager of WebKit security and privacy for Apple. And this is Lucas Weichelbaum, by the way. He's senior staff information engineer at Google, and Lucas is one of the creators of the CSP3 standard. So he shows up in this thread and says, hey Apple, I'm a lead engineer from Google. Would you take a PR? Because I'll use my time as a senior engineer at Google to fix WebKit so you kids at Apple can get CSP3. This is smack talk of the biggest type. And Lucas needed to get approval to say this. So he's like, and so his boss is like, go for it. Let's help Jim smack talk Apple. So Lucas is getting involved saying, I'm going to help you fix this, Apple. There's a lot behind the scenes here over private messages. And John Weilander at Apple says, absolutely, Google. WebKit is open source. It's not just Apple building the web platform features on it. So Sony and Igalia do tons of work. We haven't expressed opposition to CSP3 beyond some blah, blah, blah. Yeah, but here's the standard body lead right there. Hey, what's your opposition? What's wrong with CSP3? In our experience, strict dynamic, the CSP3 main call, makes an effective CSP easier and possible as more backward compatible. So John's saying he has problems why he doesn't want to implement it, and Lucas is like, the only problems are you're not implementing it. If you get this live, it's going to make rolling out the standard easier. That's why we created CSP version 3.0, and you're getting in the way, John. And so what happens here is this. So I agree that it would make sense to fork it off the scripting part. There's something else going on. Yes, the point Lucas is making here, regarding strict dynamic PRs, I need to talk to some folks, but we'll reach out again. Now what's happening now is Lucas just got budget to bring in 4 or 5 contractors to build CSP3 in WebKit for Apple as a Google engineer. And John Weilander is having talks with his bosses, and they're going, how come Google is fixing security in Safari, John? What's going on here? So behind the scenes, 2 of the biggest software companies in the world are debating what's going on Twitter right now, and why are our executives debating what should and should not go into Safari, and why is Google offering to build it? So John shows up. So Kate Cheney from Apple immediately starts working on this the next day. Yes, let me repeat this. Kate Cheney from Apple begins implementing CSP3 in WebKit, and sure enough, Safari 15.4 comes out with full support for strict dynamic, and now it's fully supported at the standard level in Safari, and so every major browser in the planet supports our dear old standard that started with Robert Hansen back in 2004, Content Security Policy 3.0, and it does make me beam with joy. And I do thank John Weilander and Kate Cheney and even Chris Christoph and Lucas Weichelbaum for helping me push Apple a little bit into getting this done. So this critical security standard is truly live in Safari. And now today, 2022, Content Security Policy 3 is everywhere. Catherine Cheney built it for Apple for Safari. On the far right, we have John Weilander, who runs the security team for Safari. In the middle, we got troublemakers, Michelle Spagnuolo and Lucas Weichelbaum at Google, 2 of the standard body leads, 2 of the sharpest people and research scientists that have explained to the world how to use CSP3. All together, these folks have helped make this standard a reality for modern developers today. In 2022, again, let me jump ahead. OWASP is now global foundation, 230 chapters worldwide. I've been to many of them. I've had a chance to travel the world and meet friends in every city on the planet where there's some OWASP member talking about application security. That's today. Now, what's the future as we wind down here? What is the future? Who knows? I don't know what the future has to bring. I don't think about it. I try not to think about it too much. I try to focus on today as best I can. But I do think about the future. So what is really going to impact the future the most? I think the Federal Information Security Modernization Act of this year is radically transformative for North America and the US. NIST 863 and 853 are world-class standards and publications to help drive security forward. There is now, if you look hard enough, there's usable crypto and many frameworks, languages, libraries, and cloud services, more so than ever before. Microservice security, we understand it now, and we can do good microservice security without sacrificing performance, the whole point of microservices. We got that locked down well. We got GDPR and CCPA in California, real privacy law changing the world. We got SBOMs. We got supply chain focus. We see Log4Shell. No one even remotely doubts that getting your supply chain locked down is critical to secure the world's infrastructure. We see threat modeling with the threat modeling manifesto. Jonathan's one of the authors of it. Say hi, Jonathan. Yeah, threat modeling manifesto comes out and kicks off the true modern threat modeling era where we're actually getting it right and making it useful. Rust, a memory managed language, can be used to build the Linux kernel now. We got OPA, the Open Policy Agent, giving us microservice access control infrastructure. We got DevSecOps. It's not just a word, it's what most of us are doing. And we see tools like SemGrep and CodeQL that are transforming the security tool landscape. That's where we are today. Remember where we started, hammer and nail. And where are we today? We have a mature industry, mature capability, and everyone in the security industry knows about the OWASP Foundation in some way. Most developers do at this point. We are making a difference. But the real future, what does the future have to bring? What is the future of OWASP? What is the future of application security? What is the future of those of us who are trying our best to secure the world's software infrastructure? The future of application security is you. Thank you for being here at this conference. Have a great day. All right. Any questions? Have a great day. Thank you all for being here. Enjoy the rest of your conference. Thanks again, everyone.